Hello, and welcome to Towle Talks. Today we switch gears and start talking about the database. So the database is going to be very important. And I'll be honest with you, that database is going to make or break your web application as far as functionality goes. You might argue that the visual could break the web application because people won't want to use it. But as far as functionality goes, the database is where it's at. It's very important. If you skimp on the database design or you have a non-scalable database design, it's just going to come and haunt you. So today we're going to talk a little bit about this. This particular class is not designed to be database heavy, but we're going to mention some of the key rules to follow, and hopefully you'll see good practices in designing the database. Also, we are going to start working on a little web application, or I'm going to start working on a little web application called Hoot, which will be kind of mimicking Twitter, and this will be used throughout the next couple, if not the rest of the CodingNighter tutorials. So please make sure you have this database set up, because from here we're going to move on and start developing a web application in over a set of different episodes. So again, think of the database like building a house. The database design and setting up the database is like digging the hole for the house. Setting up the model would be like pouring the foundation. Setting up the controller will be like the scaffolding and perhaps the walling. And then setting up the views will be like the paint and the cosmetics at the end. So if you just have a really poor foundation or poor hole dug for your web application, you're going to have problems much later, and it's going to become a lot more difficult for you to fix. So for review, make sure you have a good understanding of controllers and views in CodingNighter. We'll be using those shortly. We're going to start with the database now, so we're going to be working our way back to the controllers slowly, but make sure you can use those when needed. So normally you would design a database, the whole database, with list out all your tables you think you need, figure out how they relate to each other. We're going to do it a little bit differently because I want to show you how to make a table in a database, and then we're going to go back to how we design the database. So here we're going to deal with setting up a table, which again would actually be the secondary step you would do. And then we're going to revisit what the database we want Hoot's database to look like. So, like I said, I'm going to assume that you've had exposure to databases before and have had a little bit of experience. Generally speaking, when you design a database, you want to make it be very careful with it, because a database will make or break your web application. Usually you set out a list of tables and figure out how the different tables relate to each other before you start worrying about what goes into an individual table. However, if you do not have experience with this, this can be kind of an arduous task. So what I'm going to do is I'm going to kind of do it reverse. We're going to start with the user table. We're going to pretend like we're going to build that, and then we're going to go from there. We're going to try to figure out what we need for the other tables. And this might be more closer to how a beginner or novice person with a database starts out thinking about it. So again, we're making a web application called Hoot, which is going to be a lot like Twitter. We'll let the user post 128 characters or maybe 255 character messages, and the user can vote and rank other users' Hoots. So that's basically what we're going to have for functionality at the moment. So if we were going to try to make a user table, just brainstorm, make a list. What do you think would go into this user table? This might be the list you come up with: a username, a password, a column for Hoot, an email, the liked Hoots for that particular user, the first name, the last name, and the role. And that, again, this would just be like brainstorming. Now, if we think about that, though, there's a couple problems, and this is the whole point. This is why I'm going through this process. The hoots and the liked hoots, you think about it, this can be one to many. So one user will have many hoots, and one user will have many liked hoots. Therefore, this needs to be its own table. How do we relate the two tables together? We'll deal with that in a moment. But the hoots and the liked hoots are going to be on their own table. The other thing is the role, like in a role in this case, can be like admin or user. We want only one of a select few options. We don't want just the user to be able to type whatever role they want here. We want the user to either be a user or admin. Therefore, in this situation, we are going to have a role here, but it's actually going to be a foreign key to another table where we have a list of the different roles. So in a situation where we have a column that's going to contain a discrete value, or a value that a certain set of options that is going to be reused across all the different users, we want to have a foreign key for that. So role is a typical one you do for that. And likewise with hoot and liked hoots, since it's a one to many, so one user will have many of these and one user will have many of these, then we're going to have another table, and we're going to have a foreign key for that. So again, whenever you have one to many relationships between data, you need a foreign key and more tables. Whenever you have a specific set of options, a field must be a specific set of options, you should have a foreign key for that. For example, the roles. And the reason is yes, I could just type admin or user in the actual user row, but I can't store any extra information on that. If I wanted to store a description, or maybe some other values or other metadata that go with that role, now I have to store all that information in the user's row instead of having it stored in its own table, which means every user that's just a normal user, not an admin, is going to be duplicating that information. Therefore, we do not want to duplicate information on a database. Also, so I didn't mention, all tables except perhaps pivot tables, and this is debatable, but maybe not pivot table, but except for perhaps pivot tables, all tables should have IDs that are auto increment and primary keys. Okay. Today we are going to start using PHP MyAdmin. So the first thing we have to do is make sure we start our MySQL. Again, now we're going to be using the database, and we're going to, next lecture, be talking about using the model. So we have to make sure that this is started. Up until now we only needed Apache, now we need MySQL started. If you go and just type localhost, once these two are started, you'll get to the main exam page. And then up here you can click PHP MyAdmin, and it'll take you to PHP MyAdmin. And here we can make databases, make tables, do whatever we need to. So the first thing we're going to do is we're going to create a new database, and we're going to call this Hoot. Don't worry about these other options right now. That'll be good enough. We'll say create, and now we're going to create a table, and we're going to create the user table. Now normally we would do this after the design, but just because we haven't created a table yet, I figured I'd show you how to make a table. Then we can worry about how the database is going to fit together. Now, there are two different schools of thought. If you're using PHP admin, it's actually fairly easy to add the foreign key constraints after you create the tables. If you're using command line, you'll start with the tables that do not require foreign key constraints and work your way up, and then add the foreign key constraints while you create the tables. So I'm going to do it the first way with PHP admin, but just be aware that there are different schools of thought. So here we're going to say we want user, let's say users. A convention is really important here too. You want to make sure you have a good convention for your tables. So we'll make our tables plural, and we'll make our values singular. That'll be a good convention to use. And then we'll have to remember what did our table look like? 1, 2, 3. No, so 3, 4, 5, 6. Okay, I thought it was 6. All right. So we're going to look at our table again. Hoot and liked hoots are not going to be there, so I can just copy this or bring this over here. So we'll say 6 row or 6 columns. We'll say go. Now here again, I'm assuming that you've had exposure. I'm going to do first capital, everything else is lowercase. I think I changed conventions on the PowerPoint, so this is except I made one mistake. Okay, so I also want an ID. So because we want an ID, I'll do ID. And this is going to be auto increment and a primary key. So we'll hit go. So I make this auto increment, this ID becomes the primary key. And again, except for the odd case you have a pivot table, almost all tables will need IDs. Then we'll have username. Well, we'll just do user because that's the singular of users. This will be varchar. We'll say 128. It's the size of characters. We'll say we have an email or password. That'll be varchar. Let's make this 128. I'll show you what we're going to do with the password here in a minute. What else are we going to have? We're going to have an email. Which will be a varchar. $128. And then we'll have a first name. And we'll have a last name. Again, this is not really designed to be a database class, so I'm just showing you really quick how to make a table. If I need to add another column, I can go up here and say add a column. If I have too many columns, as long as I don't have anything in it, it'll be ignored. So ID, user, password, email, first name, last name. I believe that's all I needed for our. Oops, keep that. Roll. I forgot roll. I do need it. So I'll say go. So now we have another column pops up here. Now this is actually going to be a role ID. This is going to be a foreign key. So what we're going to say is we're going to say role and then underscore FK for foreign key, not anything else. But it's going to be an int. And the reason it's going to be an int is it's going to be pointing to an ID in a different table. So we'll come back to this one. We're not going to do the foreign key right now because we don't have that table made. So when I have this finished, I can go save. Now, word of warning. Okay, so if you hit save on this PHP MyAdmin, it will actually run the SQL, which will show you a little bit misleading when we do inserts, but I'll show you that in the next lecture. So here we have our primary ID, user, password, email, first name, last name, and role FK. Now, I do want to make this an index. Anything that's going to be a foreign key has to be an index. So we're going to go over here and make this an index. Just hit OK, and now this should, well, it's been indexed. It should go down, but let's see. Well, actually, there's an easier way of doing it. Let's see. We can go to relationship view real quick, and oh, we don't have any other tables. So when we have another table, we can create a foreign key down here, and the column we can choose, they'll let us choose the role FK because it's indexed. So that will be it right now. Again, a very quick introduction to database, but now we have set up our so we made one table. We've talked about what goes in it, what doesn't go in it. Now before we go any further, in fact, we should have done this before we started making the table. Again, it was just a demonstration to show you how to make a table in PHP MyAdmin. We should figure out how the tables relate to each other. Once we do that, then we can build the rest of our tables and set up our foreign keys. One thing to remember is you are not going to be able to plan for everything. So scalability in your database design is going to become crucial. I've purposely left things out of the Hoot database because we're going to be using things a little bit later that we don't know about right now. And I purposely have done that so we can see how to scale the technology out. If you have a good design, you can scale your database to handle more functionality. If you have a poor design, you'll end up in a corner and then you'll have to do all sorts of weird things. The last thing you want to do is create a situation where you have to go through and edit existing data in your database. So when you scale, it's almost always going to be with new tables that are pointing at existing data or tables with existing data in it. So we'll talk about that a little bit later when we add some more functionality to the Hoot. So we've just made our first table. We just demonstrate how to use phpMyAdmin, but normally you would do this later. Normally first you would plan out the database and figure out how your database is going to work. We know that our Hoot table is going to have a foreign key to our user ID because we have to have an author ID. And we know that the user ID is going to have a foreign key to the role table. We already talked about that for users or admin. And we know our like table is going to have a foreign key from our Hoot to our user table, or Hoot and our user table, because we have a user ID and a Hoot ID that we're going to be keeping track of. And the reason you want to make these foreign keys is you don't want to have a like entry that's pointing to an invalid ID for a Hoot or a user. That would just break your web application. So if you keep your foreign keys in place, then you can't delete anything until you go, in this case you have to start with the like table, then the Hoots, and then the user if you wanted to say delete a user. So usually you plan this out and you can graph this out in a relationship diagram. There's a couple different ways of doing it. This is a simplistic version. We know the user is going to have a foreign key constraint to role, so whatever the role ID for each user is, it's going to have to be a valid ID in the role table. We know Hoot is going to have author ID, which is going to have to be a valid user ID, so there's going to be a foreign key constraint here. And we know the like table is going to be a valid key constraint for Hoot and the user ID. So once we have established how these four tables are going to relate to each other, then we should go to the task of figuring out what each of the columns are going to be for each table. And this is what I've come up with. We've already done the user table. The role table will be ID, role, and a description. The Hoot table will be ID, author ID, message, and date. And then the like will be ID, user ID, and Hoot ID. These two will be foreign key constraints to ID and to Hoot ID. And in the rank the user gave it and the date, this author ID will also be a foreign key constraint to the user ID. All right. Now that we have our table set up, let's finish the database. Now we've designed our database, I should say, let's finish the database and add tables. So what we can go is click on Hoot over here on the left side, and we can add a new table. So let's add, for the first one, we're going to add, the table name will be roles. Again, we'll make this plural. So we're going to have ID, this is going to be the auto increment primary key. So we did before. We'll have role, which will be a varchar I guess we make it actually lower than that. We'll say a varchar 16, because it really doesn't have to be that big. And then we'll have a description, which will be a varchar 64. Now this is an example where we have one extra we don't need, so we're just going to ignore this. Let me double check that. I don't think we have anything else for the role table, right? Nope. So we don't have anything here. We're going to just hit save now. Now we have the role table and we have the users table. We want the foreign keys role FK to point to this ID. So in order to add a user, it has to have a valid ID. So we'll go here. We're going to click on our user table. We'll go to structure, We're going to go to relationship view, and now we'll see foreign key constraints. On delete and on update will be restricted. And because we made our role FK index, we can use that as a foreign key. So we're going to select our current field we want to make a foreign key to, and then we're going to say what database is Hoot. We're going to go to roles, and then we're going to click on ID. So now when I add or delete, if I try to delete this role, if any of these users have that role, it won't let me. And if I try to add a user with an invalid ID, it won't let me. So go ahead and save this, and now I've created a foreign key. So I think if I do this, it shouldn't break here. So being this is auto increment, I don't have to put anything there. We'll say Bob. We'll try to make a user. Oh, by the way, if I go to insert, I can try to insert data. There's an easier way. It will make this an easier process later. Bob at bob.com. Bob. And now I go here. Normally it would give me a drop down, but because this one is instant, I'll just try to say okay 1. Now I hit go. It's going to give me an error because I have a foreign key constraint and there is no role ID. So there are no role IDs. I cannot create any users until I create roles, which is what I would want. This protects me from having erroneous IDs for other tables. So I go to roles. We'll add 2 right now. Insert. Keep that blank. We'll make this admin. Admins can do what they want. And then we'll say, and now here's the tricky part. If I hit go again, I will re-add this. But if I look at my role table, you'll see that I've already added it. So don't hit go the second time. So if I say user, users can only edit their own hoots. So that's actually already been added. So now if I go to roles, now I see that I have 2 different roles with 2 different IDs, 1 and 2, because these are auto incrementing. Now that I have roles, I can go to users and actually make a user. So we'll say Bob at bob.com, Bob and Bob. And now notice, because I have actual values, I can select something. So if I select 2, so Bob's just a normal user, I hit go, and now it will actually, I do not want to hit go again. If I go to users, you'll see that Bob is here. Now, if I go back to my roles table, and I try to delete user for some reason, it won't let me because there's a foreign key constraint, and I have a user that's using this role. So that gives me some protection. So now we go to Hoot. We'll go to create table down here. We'll say this will actually be the Hoots table. So Hoots, how many columns do we have on this? 1, 2, 3, 4. Perfect. So this was the ID. This is going to be auto increment. This is going to be the author ID, which will actually be the foreign key constraint to the user table. This will be the message. We'll say author underscore FK. What did I call the other one here? Yeah, okay. Author underscore FK, message, and then we'll have a date. And date and time. We'll say just date time. Now this can be kind of tricky when we do date times of databases, so we'll talk about this one here, but this is not too bad. And that will basically be our Hoot table. We'll hit save. Now author FK is going to be a foreign key, so we're going to make this an index. Again, if you were doing this on console, you would do this while you're creating a table, but it's easy in PHP admin. Then we can go to relation view, and we can say, no, hold on. Okay. Structure, relationship view. There we go. I'm not sure what happened there. And then we can say column author FK goes to table users ID. So now all Hoots have to have a valid author ID from the users table. And I cannot delete a user until the column, all the users IDs have been taken off the Hoots table. Hit save, and now I have completed the foreign key on my user. So if we go back up to this diagram, I've completed this foreign key. So the last table we have to make, we go to Hoot. We'll make the likes. Again, how many? I think it was 5. 1, 2, 3, 4, 5. Yes, 5. Say go. This one's going to have two foreign key constraints. Now this one, it could just be a pivot table. If all I had was the author or the user ID and the Hoot ID, you could call that a pivot table. Because I might want to store additional information like the vote the user gave or the date the user liked it, then that's going to make it its own information, and I'm going to have an ID. So if you're thinking about this, or if you know someone who has a database, or maybe you know a database and you're thinking, you could just make that a pivot table, you are correct. I could make this just a pivot table. But then I wouldn't be able to, it would be very difficult to store extra information. So ID will be auto increment. This will be the user underscore ID. This will be an int because it's pointing to an ID. This will be Hoot underscore, FK. Both of these will be indexed. This will be the rank. I will say rank. And then this will be the date. You have to be a little bit careful here because if I remember right, date, if you have date as the actual name, it does something weird. So we'll say date liked. This will be a date timestamp. We're going to save. And then so this, the user FK will be indexed, and the Hoot FK will be indexed. Now, if I go to my Hoots table, refresh it, go to structure, relation view, I'll see author FK. Yes, I want that. Oops, not Hoots. I'm sorry. My likes table. There. We'll say user FK. We'll go to users ID. We're going to add a column. Hoot FK will go to nope. Add another constraint. So we have to add a separate constraint for this. Sorry, that's because this is a different table. So user FK will go to Hoot users ID. Hoot FK will go to Hoot's ID. So you have to have two different constraints because there's two different tables. Then we'll hit save. And again, this gets really messy if you're doing it all by SQL, and it gets really messy to do this after the fact. So a lot of people will do the foreign keys while they're designing tables. It's just the computer's doing it for us, so it makes it a little easier. So now these foreign keys are in place, and our database is essentially prepared for our new web application. So that will conclude it for this demonstration. Again, please pause it or replay it if you need to, and go through each table, make sure everything's set up correctly. A lot of weird little things can happen, so you may have to play around with this, but you need to figure this out, because going forward, everything is going to be built on this. In fact, the database is actually probably the most important part of a web application to design, because this will make or break whether or not your application can scale. And I'm going to show you purposely, we're going to add some new things in later that, I mean, it would have been one of those things that been nice to know right now that we're going to need this later, but we're not going to know that right now. And so I'll show you how you can scale your database with a proper design. So this will conclude how this, basically we have our database set up, and after this we are going to then go and start doing the models next tutorial. So let's review. Today we've talked about how to create tables in PHP MyAdmin. We've learned how to create foreign key constraints. We've learned basic database design and basic table design. Again, this is not really designed to be a database class, just enough to get you up and running so we can use the database to move on with models and the MVC architecture. The problem of the day. Please make sure you have today's database set up and working as I have it on the tutorial. We're going to be using this tutorial throughout the next couple lectures, so please make sure you follow along and do not fall behind. If you're in the class and you're having a problem with this, please come talk to me. If you're watching this online, again, just rewatch the video if you need to. Just make sure the database is up and working. Again, we're going to be using this tutorial for a while. Thank you for watching Towle Talks. I hope you've learned something about databases. Again, this is not a categorical lesson on database. There's a lot more information, a lot more things to think about, but just to give you a heads up on how the high-level design elements of it, and hopefully you can work through the rest of the pieces of the database, or you've taken a database class. With that, until next time, cheers. Thank you for watching this video. I hope you learned something and enjoyed it. If you did, please leave a comment or a like below. And again, thank you.